Hello everyone, welcome back to Nexus Olive Tech channel again. In previous episode, we learned how to connect a 16 by 2 I2C LCD display to an Arduino Uno and display a text on the screen. Today we are going one step further by integrating that LCD with HCSR04 ultrasonic sensor. Instead of displaying a fixed message, our LCD will continuously display the distance between the sensor and an object in front of it. For this project, we will need Arduino Uno, breadboard, 16 by 2 I2C LCD display, HCSR04 ultrasonic sensor, jumper wire. Now let's build the circuit together. First, place Arduino Uno onto the workspace. The second one is place 16 by 2 I2C LCD beside Arduino. Since we already learned how to use this LCD in previous episode, today we will use it to display the distance measured by ultrasonic sensor. Next, place HCSR04 ultrasonic sensor. Finally, place the breadboard beside Arduino. We will use it to distribute power to both the LCD and ultrasonic sensor. Wiring the circuit. First, connect 5-volt pin of Arduino to the positive rail of the breadboard. Next, connect one of the Arduino's ground pin to the negative rail of breadboard. Now the breadboard has both power and ground. Next, let's power the ultrasonic sensor. Connect sensor's VCC pin to positive rail of the breadboard. Then connect sensor's GND pin to the negative rail. The sensor is now powered. Now let's power the LCD. Connect LCD's VCC pin to the positive rail. Then connect LCD's ground pin to the negative rail. Now both devices receive power from breadboard. Next, connect the communication pins. Connect SDA pin of LCD to Arduino's SDA pin. Then connect SCL pin of LCD to Arduino's SCL pin. These two pins allow the Arduino and the LCD to communicate using I2C communication protocol. Finally, connect the trigger pin of ultrasonic sensor to digital pin 7 on Arduino. Then connect echo pins to digital pin 6. Our hardware setup is now complete. Now let's move to the code. Since we already learned how to display text on LCD in the previous episode, today we will focus on the new code used to control ultrasonic sensor. The complete source code for this project is available on my Telegram channel, Nexus Olive Tech. You can download it from the link in the description. Let's understand the new part of the program. First, we define the trigger and echo pins. This line tells the Arduino which pins are connected to the ultrasonic sensor. We also create two variables, long duration, float distance cm. The duration variable stores the travel time of ultrasonic wave. The distance cm variable stores the calculated distance in centimeter. Inside the setup function, we configure the sensor pins. The trigger pin is an output because Arduino sends a pulse to the sensor. The echo pins is an input because Arduino received the reflected signal from the sensor. Inside the loop function, the first line is serial.begin 9600. This starts serial communication at 9600 bit per second, allowing us to view the measured distance in serial monitor for testing and debugging. Next, we prepare the triggered pins. We first set the trigger pin low for 2 microseconds to make sure the sensor starts from a stable state. Now we send the trigger pulse. HCSR04 requires 10 microsecond high pulse. Once it receives this pulse, it sends out an ultrasonic sound wave. Next, we measure how long the sound wave takes to return. Duration equal to pulse in. Function measure how long the echo pin remains high. This time represents the round trip travel time of ultrasonic wave. The measured value is stored in variable called duration. Now we calculate the distance. cm equal to duration times 0.034 divided by 2. The value 0.034 is speed of sound expressed in centimeter per microsecond. We divide by 2 because the sound travels from sensor to object and then back to the sensor. This gives us actual one-way distance. Before displaying the new distance, we clear the LCD. This line removes the previous reading, so the LCD displays only the latest distance. Next, the program print the text the distance is on the first line of the LCD, then display the measured distance followed by centimeter on the second line. Finally, serial.println distance cm, print the measured distance in serial monitor and delay 500 millisecond, waits for half second before taking the next measurement along the LCD to update smoothly. Now let's upload the program. As you can see, the LCD displays the distance is on the first line. On the second line, it shows the measured distance in centimeter. When I move the object closer to the sensor, the displayed distance decreases. As I move it farther away, the distance increases. The LCD updates continuously, giving us real-time distance measurement. Before we finish, let's briefly understand how HCSR04 works. The sensor has two circular modules. One acts as a transmitter, while the others act as a receiver. When the Arduino sends a trigger pulse, the transmitter emits ultrasonic sound wave. The sound waves travel through the air until they hit an object. The waves then reflect back to the receiver. The sensor measures the travel time of the sound wave, and because the speed of sound is known, the Arduino calculates the distance to the object. This technique is known as time of flight measurement, and it is widely used in robotics, obstacle avoidance, automatic door, parking sensors, and many other embedded systems. If you enjoyed this tutorial, please like the video, subscribe to Nexus Olive, and share it with your friend. Thank you for watching, and I will see you in the next episode.